Thank you. So I'm really happy to introduce our next speaker, Catalina Munteanu from the University of Freiburg. And yeah, thank you.
Okay. Well, thank you very much for having me. Thanks for bearing with us through the siesta time with us non-Spaniards. I'm going to talk to you about land use histories and their implications for conservation action. And it's become almost cliche to start a talk about, by highlighting sort of the unprecedented environmental changes that we're facing today. May it be climate change or wars or land use change. But less often, we tend to hear about past land use changes and past human environmental influences and how the things that we are experiencing. So how the processes and the land use changes and environmental changes that we're seeing today are actually related and rooted into much older pasts. So here, Industrial Revolution, the Two Worlds War, or the Green Revolution, just to name a few global events that are potentially behind many of the processes that we see today. So my thesis today is that only by understanding the contemporary effects of such past land use changes will we actually be able to respond in a sustainable way to the environmental processes and changes that we see today. And to demonstrate this and to put some data behind this statement, I will show you how we integrate different data sources in order to understand the effects of these past historical events. And some of the most commonly used data for biodiversity analyses and for environmental change detection come from remote sensing. So this is a list of remote sensing data sorted from coarse resolution at the top to fine resolution at the bottom, and it has the temporal resolution on the x-axis. So you see that most of the remote sensing data that allows us to reconstruct environmental change at broad scales goes back only to the 1980s. However, one of the main limitations, although this is super useful, this data, of course, has the enduring limitation of time. And we're working on trying to extend this data. We have already seen some examples. One other data set that we are currently working with are spy satellite images from the Cold War era. These are data that were collected by the US Navy and Army in order to identify the locations of Soviet nuclear missiles during the Cold War. And just very briefly put, you can imagine them as being sort of Google Earth in black and white. And this data allows us, there are different satellite sensors that have collected this data. The data has been declassified for several decades now, and I think it holds a lot of potential for ecological research. And it allows us to expand the time series of remotely sensed data globally as far back as the 1950s and 60s. And if we need to go even farther back in time, we can reach even farther back using also data that was collected for military purposes, and you've seen a lot of that today. Dominic has showed you some examples from the area that I come from, the Carpathian region. Empires were keen to map their territories, and they did so very assiduously and very accurately, and that allows us to also extend the temporal extent of data as far back as 2 centuries ago. And then I'm a forest ecologist, and in forestry we work a lot with forest management plans and forest inventories, like you've heard, which is also an additional data source that is available to us for purposes like that. So what I'm going to do in the following minutes that I have allocated to my talk is show you how we combine some of these data sets to look at conservation and land use change questions. And I start with an example from Romania. I originally come from Romania, so it's a place very close to my heart. And this Romania, you might have seen it in the news quite often, and it has been there because of the high rates of forest disturbance and harvesting and lots of illegal logging and so on. Some of the reportedly highest rates of forest harvest in Romania have happened in the decade immediately following the collapse of the former Soviet Union, so in the 1990s. And with remote sensing data, with modern remote sensing data, we identified this period, 1990 to 2010, as being the highest rates of change. Romania lost some 200,000 hectares of forest in those 10 years. But when we actually go back in time and use the SPY satellite data that I showed you, so when we change the baseline against which we monitor forest loss in Romania, we actually found that 1955 to 65, Romania was losing 3 times as much forest as it was in the period that we thought was the highest rate of deforestation. So just for comparison, I'm going to go back to these map here. Green are the areas that stayed forested, and red are the areas that were harvested. Now this was because Romania was on the loser's side of the Second World War. It was a poor country. It had to pay a lot of war reparation debts following the Second World War to the Soviet Union, and it did so using natural resources, so oil and timber. Hence, the massive deforestation that you can see here in this picture. This is an example of an excerpt of one entire basin that was clear cut for those purposes. Another example of what changing the baseline against which we change, how it might affect our interpretation of changes is work from the Tibetan Plateau, where there are a lot of small freshwater lakes, which have increased in their surface area dramatically due to climate change. There's not much human influence there otherwise, so we can be pretty sure that whatever we monitor there in the Tibetan Plateau is related to climate change. So when we look at this particular lake, since 1994, we see 150% change in the surface area of the lake. But change the baseline and add another time period to the story. And if we compare the current extent of the lake to 1969, we actually only find a 50% change in the lake surface area. And this is just an example of how perhaps some of these changes might actually also be related to background climate variation, not just to the anthropogenically caused climate change. But the point that I want to make with these two examples, both the Romania one and the Tibetan one, is that changing the baselines against which we measure our changes may lead to actually very different conclusions. So we need to be very careful about how we pick those points in time. Unfortunately, oftentimes these are just very much data-driven or preference-driven. And just a note of caution. Why is this important? Because these changes that have happened in the past have actually very large effects on our ecosystems today. And here again, another example from Romania, where we compiled the war reparation payment harvests data with forest management plans and forest inventories to look at species composition, and found that we found a massive increase in the spruce abundance and proportion in the different regions of the country, and a heavy decline in the beech. And this is because these areas that were harvested for timber in the 1950s and 60s for the war reparation payments have then been massively planted with spruce, and that drove change in the species composition today. So historical management can affect species compositions for very long time in the future. Now, this spruce has actually come to harvestable age but the composition of the forest, even after the harvest and the natural regeneration processes being promoted more in Romania these days, the composition of the forest still stays very different than that in the past. And legacies can go even farther back in time, and I showed you the example, or I showed you on this initial graph historical maps, and this is data that comes from these studies that were done in collaboration with many partners across Eastern Europe, showing that there are legacies in the rates at which the forest is changing. So we went back, and Dominic showed part of this, we went back to the 1860s and then modeled the occurrence of forest disturbances in the recent period as a function of historical forest cover or land use cover. And we found a 50% higher odds of disturbance in those areas that were not forested 200 years ago compared to areas that were forested back then. So the message here being that historical land uses can affect the rates of change, of environmental change, even centuries after the land use. And this holds true also for agricultural change processes. So this, the pattern was the same there, where the rates of agricultural abandonment were much higher in areas that were used for agriculture for a shorter period of time. Now the question is, can we use this sort of long time series of information that we collate and combine in order to inform conservation actions? And I would argue that yes, we can. Romania is a place where we have a lot of valuable forest ecosystems, and we started off on an attempt to actually map these valuable forest ecosystems. We call them high conservation value forests, using these long time series of historical data. And in order to do so, we started off by putting together all the forest cover time series that we had at hand and created a continuous forest cover map. And then we produced two models, one looking at forest structural complexity. This is solely based on modern remote sensing data that is trying to predict how complex the forest canopy is. We trained this model with data from the location of known primary forests in Romania, and we produced a structural and compositional complexity index. And then we ran a second model that looks at the anthropogenic pressure on the forest. So this is a measure of how accessible the forest is, how many houses are heated with firewood, and what's the road density and so on. So we produced a model that, or an index that indicates how high the anthropogenic pressure is on the forest. And then by putting the two together, we were able to identify where those areas of high conservation value are. So these are the areas in green on the map, which are forests that most resemble primary forests based on the historical time series and have low anthropogenic pressure. At the same time, we identified where the areas that are at risk are, so these risk high conservation value forests, so where the structural complexity of the forest is high, but the anthropogenic pressure is high as well. And also legacy forests, we call them, so areas that have been used and harvested for a long time and where the likelihood of reaching a structural complexity remains low in the future. And hopefully this can become an important tool for planning, conservation and management action that actually takes into consideration the historical time series. And hopefully this is something that the Romanians will then take and implement for prioritizing forestry practices and conservation practices. For the last part of my talk, I want to continue showing you examples of how historical data can sort of change the way that we interpret the processes that we see in our environment, but I'll take you to a very different ecosystem now. This is the steppe of Kazakhstan, where steppe marmots are at home. And These marmots are great to study because they are great indications of the steppe ecosystem health at large. They are also great to study because they build burrows in the soil, and these burrows are visible from space as these little white dots that you can see here. So we can map the burrows of the animals and obtain an estimate of the species abundance. And we can do this, of course, over time. So we used a lot of manpower to identify some 12,000 burrows of these marmots in Kazakhstan. And what we found was very interesting to begin with. We found densities of marmots being higher in croplands compared to grasslands, which was already surprising because we would expect that the marmots would be in their natural ecosystem, the steppe, the happiest. This was not the case, but even more surprising was that when we added the historical time series, we can also see these marmot burrows in the SPY satellite images from the 1960s, we identified a 14% decline in the marmot population, and all of a sudden the picture becomes much more complex. We see that this decline stems primarily from declines in the cropland areas, whereas the species actually increased in grasslands slightly. Now this is because, like with the war reparation payment harvests in Romania, Kazakhstan went through, Kazakhstan went through something that was called the Virgin Land campaign. The Virgin Lands campaign was a massive campaign to convert the steppes of southern Russia and Kazakhstan into cropland that went and permanently changed the land use of the natural habitat of the marmots and caused these declines. What we think that we're seeing here is a time-delayed effect to these historical conversions. It takes the marmots 1 or 2 generations to actually disappear from the landscapes because they're a philopatric species. What this means is that they tend to come back and live in the same houses, in the same burrows for generations. But agriculture keeps disturbing these burrows over time, and after several generations they give up and disappear, and this is the drop that we see that we wouldn't have seen or wouldn't have guessed with contemporary data alone. So the message that I want to send here is that not only can we have effects in species composition and rates of change, but that these effects can come with a time delay, depending on the species that we look at. So this is all work that I have carried out until last year when I started a new position at the University of Freiburg. It's all very exciting, but one thing that I increasingly got interested about as I moved to Freiburg in a very interdisciplinary project is the social component and the human component in this whole process. Of course, there is this effect of people are changing the environment, and that's what we're mapping, but how do people perceive these changes? And how does that perception of long-term ecological change affect the way that we are making conservation and management decisions? And there has been a lot of literature out there saying or showing a process that Jens mentioned earlier as the shifting baseline syndrome, which refers to the fact that as an ecosystem changes, so we see a decline in the forest cover or an increase, recovery of the wolf population, and we choose a point in time to compare that with. When we ask people about how things have changed in the past, they very much relate these changes to their own life experiences. And there has been quite a bit of evidence coming from Molly's group and other groups in the UK showing that this is related to age, and that older people tend to be more accurate in placing this point in time than younger people because they relate to their life experience. The difference between what a person would remember as the historical state or the selected baseline and the baseline that we choose, so this part here is actually termed the shifting baseline syndrome. So this unrecognized change in the system that we oversee, that we're blind to. And this is problematic because especially when conservationists or managers are affected by this shifting baseline syndrome, then they tend to make decisions that are sort of oblivious of the historical state of the ecosystem. This can be both this is valid both in terms of ecosystem declines or losses of species, but also in terms of recovery, it could be problematic. And the last thing to say there is that I'm becoming increasingly interested of moving away from this age aspect, which is pretty well documented, into understanding what other aspects of our personal identities makes us more prone to shifting baselines. So is it the way our work patterns, our living patterns, how often we move, and so on and so forth. And like I said, the age-related aspects have been very well documented from the fisheries. This is work that Daniel Pauly had started in Canada, where they have shown the change. These are pictures taken at the same fishing dock over time. So you see that the average size of the fish has changed from some 20 kilograms in the 50s to 2 kilograms in 2007. Yet when the fishermen were asked at the fishing docks about their catch, everybody described this situation as a very good catch of the day. So our perception of things is shifting over time, and this perception is different across age groups. So I'm becoming increasingly interested to look at this in the context of other ecosystem aspects, other biodiversity aspects, and I'm currently planning a project that is comparing the perception and the ecological change of selected bird species and tree species in southern Germany, where we're based, where we're trying to identify, on one hand, the environmental change, the change in abundance of these species and these trees, just like with the many examples that we have seen today, and compare that with the perceived change that we measure through questionnaires and through surveys in the population. People might have an accurate perception of the change, or they might be prone to misperceiving things. These are terms that Lizzie Jones from London has used to identify memory illusion and change blindness. So when people are completely off, there is change, but people don't remember it, or there is no change, but people are actually seeing change. The part that I'm most interested in here is measuring the magnitude of this shifting baseline syndrome. So when we know that there is a change in the system, and when people perceive a change, the magnitude of that change is different. How different is it, and what drives it? And so this is an element where I've heard a lot of examples today and yesterday about changes in species population, and I'm very, very keen to actually compare that with human perception. And this is important because when they don't align, we have to do with this mismatch. And I think choosing our environmental stewards or choosing those people that have the lowest mismatch in their perception as our environmental stewards is incredibly valuable. And eliminating that mismatch for people that do have it is also incredibly valuable. That's not to say that we want to restore things to a historical state. By no means. I'm of very strong opinions that there's no ways that we are going to restore the ecosystems to how they were in the past, and there's no need to do so because the climate is changing, the land use is changing, the needs of the people are changing. But what we need to know is how things were in the past in order to be able to understand the system. This is something that has been pointed out several times today. So, shifting the baselines against which we measure change may lead to very different conclusions, and I showed you that with examples from Romania and Tibetan Plateau. And the way that we manage the land in the past can affect the ecosystems today in many ways, in terms of species composition, in terms of environmental rates of environmental change, but also in terms of time delays that we might see in the system. And we can only really act on these things if us as people are aware of these changes and can understand these changes to the real extent in order to make sustainable decisions for the future. So with that, I come back to my first statement that only by understanding the contemporary effects of past anthropogenic changes will we be able to respond to them in a sustainable way. Thank you very much for your attention, and I look forward to your comments and questions.
Gracias. Thank you very much. Do we have questions? Yes, I see two. Three.
Thanks. Cool. Thank you, Catalina. That was fascinating. I'm just thinking about some of the implications of your the work in the latter half of your presentation. I'm curious kind of how capable people are, according to the research, of correcting inappropriately chosen baselines when confronted with evidence of their inappropriateness. I need some hope for the future. And also, relatedly, kind of, are there studies on the electoral implications of this? I mean, do we know how this translates into actual behavior that might have a consequence for environmental management, conservation? Thank you.
Very rough questions, very hard questions, but very valid questions, I think. So this is what I would like to learn and understand, is if you are confronted with the information, can you correct for that shifting baseline? I don't know. I don't know if people can do that, and I'm purposefully not trying to achieve that with this first study, because I think so this is, I'm running this through an online survey where I'm presenting people with images of trees and birds, and I'm asking them, how has this changed? If I try to do that in an online survey, I think I miss half of the story. And I would like to confront people with the historical data in a completely different setting, in an open setting with people in the room. I would love to learn that. That would be the next step. I know that there are certain groups that have done, and there's mixed evidence on this from the literature. There's also mixed evidence that people do experience shifting baseline syndrome or not. So my first attempt is to understand if that's really a phenomenon. Some people say that conservationists do experience it. Others say that they don't. So it's a very tricky process, because you have to disentangle people's memories and from sort of more general things of like information flows and things like that. So I can't give you the hope just yet, but I would hope that I would give you the hope in about a year's time. There's a very interesting, so in changing behaviors, there's a very interesting study that I remember from Molly's group on popcorn consumption after seeing a BBC Planet Earth series. So there was a grad student at Oxford University where they have invited people for a showing of the BBC Planet Earth series. Please correct me if I'm wrong, Molly. I'm trying my best. And they have offered them popcorn packaged in paper or plastic. And they looked at what people picked. And then the people went and watched the movie and ate the popcorn. Sorry? Or a non-nature documentary, exactly. And then they offered them popcorn as they walked out of the cinema hall, and they monitored if people changed their behavior in not picking the plastic packaged popcorn. Now that's super cool, but that's a very short-term effect, right? That's something that happens. I saw the movie. I'm going to do my New Year's resolution. I'm going to exercise this year, and by February I'm back on binging sweets. And we're notoriously known for doing that. So, one would have to do a really long-term study to actually measure the effect of, sort of evidence impacts. But yeah, E.J. Milner's and Molly's group in Oxford are perfect go-tos for that. I don't know about politics, but yes.
So I have Chelsea on the right.
Okay, I do want to comment on that because this relates to, there's a whole field called cognitive ethnobiology, 70s, 80s, and then it kind of fell off, but this was like the crux of what they were trying to figure out, how people think about the natural environment. And there was a really neat study by Jim Vedodo. He looked at perceptions of climate change in Appalachia among farmers, so people who have a really intimate connection with the environment. And if they were Republican, they saw no issue with their apple varieties and apple crops, and if they were Democrats, they did. So like a very, very drawn line. But that's my question. I mean, when you talk about public perception or people, are you assuming one collective people? And if not, are there factors like expertise playing in? So for example, studies of, expert mountain goat hunters, regardless of their demographic, their expertise informed their observations that mountain goats are declining versus a broader public in the same demo.
Yes, super good question. For this, I want to look at, I think I term it individual perception. So I'm not talking about people as groups, but people as individuals, where I try to look at different aspects of demographics or experience. So we're asking them, how many years have they worked in their field? How much of their time do they spend outdoor versus indoor in their work, and so on, which gets to some of the points I think that you're touching on. But then I'm still struggling a little bit, so I would love to read some of these papers. I'm still struggling a little bit to differentiate between what is an individual perception versus what is the societal discourse that affects the individual perception.
And this is where an anthropologist will tell you culture will dominate all, a sociologist will say urban versus rural, and a psychologist will say hyper-individualism.
Yeah.
The cognitive ethnobiology world is really interesting. It tries to kind of mix those things. Like Polly's example about fish, I always laugh at because, we're catching 20-pound Chinook salmon on the Skeena River, but everyone knows that's a good catch and you're happy, but everyone still references, remember the 100-pound ones? Like, it's not the baseline of being grateful isn't changing with the reality of what people used to know. So, it's...
But there's also a really interesting, sorry, I don't mean to dominate this discussion, we can take this also. But yes, climate change studies in Alaska show that, kids are completely oblivious to extent of, how much snow there is or how big the glaciers were, even though those are societies that you would think pass on the knowledge quite, or more from generation to generation. So there's this generational effect. I would love to. Yeah.
So let's take one last question before coffee.
Okay, you were talking about how historical land use changes things were more likely to reoccur in places where they'd occurred before. If something got cleared and grew back, and the inverse. And I was wondering whether that, do you know if that's caused because it's because of some intrinsic property of the land that something that's good to farm once was good to farm again, or is there a social process there where people are more likely to go back to some place that has maybe land ownership or some other social reason for?
That's a very good question, Rafael. So we try to account for most of these things to the extent that we can with our models, in that, for example, in the case of abandonment, that would be the most obvious question that one has. Land abandonment occurs most often or at higher rates in land that was used for agriculture the least amount of time. Well, that makes sense because the less suitable areas have been converted last. So when it's time to abandon, you abandon the areas that were least suitable to begin with. But we have accounted in our models for agricultural suitability, and the models have been exactly the same. And then, so we've used the same model with and without the historical land use element in it, and then measured the effect of this historical. So even when you account for environmental factors, sociopolitics, historical boundaries and things like that, we still see an effect of this historical land use. So we do our best to eliminate the effects of these other sorts of socioeconomic, political, and environmental factors. There's very interesting work coming from group in Munich with Rupert Seidel, where they show similar patterns for old-growth forests, that old-growth forests tend to take a really long time to recover their structural or forests tend to take a very long time to recover their structural complexity, so it may take up to 200 or 300 years, although apparently the forest composition and so on is the same. So there's this very long-term element there. Thank you.